Hey, RxJS best practices aren't always black and white. My name's Deborah Kurata, and I'm a software developer. I've recently started producing courses for Amazon, and I'm also a Pluralsight author. My first best practice today is be declarative. What do I mean by that? When we learned how to do RxJS, we learned a procedural approach. We create a function, and that function returns our observable. We could instead make it declarative. We do that by declaring a variable and assigning it to our HTTP GET. That variable then holds our observable. Why would we want to do that? Well, we can then compose streams of data. So when we have all of our observables and variables, we can more easily put them together and compose them. We can more easily communicate across the components of our application, and we'll see that in a minute. We can manage application state because we have access to those variables, and we can more easily react to those actions. So as the user does something, we can actually respond to it. And we'll see an example of that as well. As soon as I start talking about using a declarative approach, the first question I get is, but Deborah, what about parameters? I need to do it as a function because I need to be able to pass parameters in that I can then use as parameters to my HTTP GET. How am I going to do that if I do it declaratively? And the answer to that is go reactive. What do I mean by that? Well, let's talk through a scenario. In this scenario, you're working with your team, and each of your team members have a list of tasks that you keep the status of. You come in the morning and you want to check on everyone's status. So you want to be able to pick a user and get user information. So how are we going to do that? Well, we want to be able to react to actions. So as the user of this application, pick a different user from the list, that you can react to that. How do we do that? Well, we first start by declaring an action stream. Then we emit a notification when that action occurs, and we react to that notification. How do we declare an action stream? We start by declaring a subject or behavior subject. In this example, I use a subject. We use private to encapsulate the subject in the service. So we're creating this code in a service and we're using private so that this variable can only be accessed from within that service. Next, we declare an observable, that's our second variable here, and that exposes the read-only part of that observable. So we use the as observable to get the observable read-only portion of that and use it in our declared variable here. That way, any other piece of code in our application can subscribe to that or react to that and get notifications from the subject. Okay, so our second step then was to emit a notification. So in our same service, we can emit a notification when the action occurs. So we do that by calling the subject or behavior subject's next method. So here, when we get a new user ID, we pass it in to next, and next emits that into that subject. Then we can react to that notification in any of our code that wants to react to that notification. So we can then perform an action. So in this case, we are going to get the user information. We could also use it to get related data or to save, as we'll see the get related data in a moment. So here, if you look, each time that we select a different user, we're going to pipe it through. We're going to switch map it on the user ID, and then on that user ID that's being emitted from that user selected action observable, and then we can use it as a parameter in our HTTP GET. So we don't have to have a procedural approach in order to have parameters on our GETs. Okay. Merge map, concat map, and switch map. Oh my. If you look at Stack Overflow, it would seem that switch map is always the best practice. But that's not actually true. What the best practice is depends on what exactly you're trying to achieve. Let's talk more about that. So here again is our scenario, but in this case now, when we pick a name, we want to pick up the to-dos for that user. So we're going to declare a to-dos variable. We're going to assign it to our user selected action so we can react every time a user picks a different user. And we're going to use some kind of higher order mapping operator here, and we're going to get the associated to-dos. So should we use a concat map? Well, we can think of a concat map like a relay race. Emitted values are queued, the runners are all queued up, and they're processed in order. The second runner can never get ahead of that first runner, and so on. So it's going to perform whatever mapping operation we want, and we have to wait for it to complete. When that first runner runs, that second runner can't start taking off until they get that baton, until that first runner completes. Then they can go ahead and continue. And then it repeats. That second runner runs up. That third runner cannot start until that second runner is complete. So it retains that order. That first runner never gets ahead of that second runner. So let's look at that example in more detail. So here we're going to go back to our to-dos, and we have our user selected action again, and we're going to try out the concat map. Now, in this case, we get into the office and we pick the second user from that list to get their to-dos. And then we realize that wasn't who we wanted to look at. So we pick the third one. So that's what these numbers mean. We pick the second user, then we pick the third one, then we realize that wasn't right either. We really wanted the to-dos for the first one. So we've rapidly picked the second user, then the third user, then the first user. So what is this going to do if we use a concat map here? It's going to request that second user. It's going to wait for that response to come back. Then it gets the third user's data, and it waits for that response to come back, just like a relay race. Then finally, it gets that first user and waits for that response to come back. So this is taking more time than it actually needs because we really only wanted that response for that first user. So in this particular scenario, concat map is not the best practice. When is concat map best practice? Use concat map when emissions are processed sequentially, one at a time. So this is important whenever order matters. Examples are insert, update, and delete. You wouldn't want to do the update for a row before you did that insert. So you can use concat map in that example. You can think of merge map as something like the 800 meter. They all start just about the same time, but and then that performs the mapping operator, but the emission order is not retained. Just because you got off the line first doesn't necessarily mean you're going to end first. So again, let's talk through our example where we pick the second user first, then the third user, then our first user, only this time using merge map. So what happens is as you pick each of these, it will immediately issue the HTTP GET request. Then they finish when they finish. So the third one has the smallest amount of data, so that one finishes first. Then the first one finishes because that has the next smaller number of tasks. Then finally, our second one finishes. So merge map is definitely not the best practice in this scenario because at the end, we've requested the data for the first user, and that's what's showing up under the username. But the to-dos are for the second user. So we have a mismatch in the data that our app is going to be showing us in this case. So again, merge map is not the best practice in this particular scenario. We instead want to use merge map when we want the emissions to be processed concurrently, because that's more performant, but the order doesn't matter. So for example, retrieving related data when the criteria isn't going to be changing on you. The third one was switch map. And you can think of this as kind of changing your mind. So the coach says, okay, we're going to start this runner. No, this one. No, this one. But only one runner actually does the running. So switch map is the same way. It will stop processing of any prior emitted value and then switches to that new emitted value. And then it performs the mapping operation. And of course, it repeats. So going back to our same scenario where I've picked user 2, then 3, then 1, let's see what happens when switch map is used. So we start by picking that second one. It goes to get it. As soon as I pick the third, it cancels that second one. Then it goes to get the third one. As soon as I pick one, it cancels the third one and it starts to get the first one. The only one that completes, the only response that I get back is the one for the last one I picked, which is that first user. So in this case, switch map is the best practice. Use switch map whenever only the latest emission matters. So for example, retrieving based on a user action. It's also really great for type ahead functionality. Now let's look at another three of them: fork join, combine latest, and zip. So here's an example of fork join. So here's my first observable, my second observable, and I'm going to fork join them. So fork join is a creation function, not a pipeable operator. It waits for all observables to emit and complete. So it waits for all of them to do all of their emissions and complete. Then it emits the last value from each observable. So A is going to start off and it will emit 1, 2, 3, 4. Then B is going to emit A, B, C. They've both completed. So then fork join will take the last value from each, the 4 and the C, and that's what it will emit. Now, it might seem like it wouldn't be as useful if it's going to wait for all of them to emit and complete before it does anything. But when you think about an HTTP request, it issues the request, waits for the response, and then completes. So as soon as you get that data, it completes. So this fork join would work really well when you're retrieving data. So let's look at a more realistic example. Here we want to get all of the users. So we're going to get the array of users, and for each user, we're going to take that user information and get their to-dos. So this is going to collect all of the users. Then for each user, it's going to get all of their to-dos and map them into a single structure with the single user and their array of to-dos. We can use a fork join in this case because what it's going to do is emit every time that these have both completed. So I've gotten the user and their to-dos. Then I go get the next user and their to-dos and so on. Okay, so this is great for getting related data for each item in an array. Combine latest, it's exactly the same example. Combine latest is also a creation function, not a pipeable operator. It waits for all observables to emit at least once. So it doesn't wait for them to complete, just to emit at least once. But you need to watch out for subjects in this case because subjects don't immediately emit. Okay, so what's going to happen in this case when any observable emits? Combine latest will emit the latest value from each observable. Okay, so it's going to wait for each to emit at least once. So we're going to go 1, it's going to emit 1, 2, 3, 4, because that second one hasn't emitted anything yet. As soon as the second one emits at least once, there's the A. It's going to take the A and join it and combine it with the latest value from the prior observable, which is the 4. Then it emits the B, it's going to join it with the 4, and the C, it's going to combine it with the 4. And that's what we end up with. Combine latest is really great when you need to combine anything and you want each thing individually. So you'll use it often if you want to join all of your observables so that you only have to create one async pipe in your user interface. So here I'm combining all of the observables I want to use on a particular component's template, into one observable, so I only need one async pipe, and combine latest is great for that usage. So great for combining any data. The last one then is zip. Zip is also a creation function, not a pipeable operator. It waits until each observable emits, so each one has to emit, and then it emits the value from each observable as a set. So it kind of zips them in, and then it repeats. So here we've got our 1, 2, 3, 4 again. And as soon as the second one emits and emits that A, I'm going to get one A. It's going to zip them up. As soon as I emit B, it's going to hook it up with the second one from the first observable, and C with the 3, and it's going to toss out the 4. So that's how a zip works. So here's a more realistic example. I want to zip up, I have an array of users and their profiles, and I happen to know that they're both in the same order, so I can zip them up. The other common place to use it is when using key and value pairs on a group by. So that's where I've actually used it in practice. Okay, this talk wouldn't be complete without a few basic best practices as well. So here they are. Don't forget to unsubscribe. If you subscribe, then be sure you unsubscribe. Or better yet, don't subscribe at all. Instead, use the async pipe. The nice thing about the async pipe is it automatically subscribes, automatically unsubscribes, and it re-renders on each emitted item. So every time a new item is emitted, it will do change detection and re-render. Don't forget error handling. You want to handle your errors. And you can catch them using code something like this. So we can pipe it through and do a catch. And here we're calling a function. And that function would look something like this, where we're going to take in our HTTP error response, and we return an observable of never, which emits no items and never completes. And that's the best one to use for error handling. Otherwise, you could get a type error. And then, of course, we'd want to ensure we don't nest subscribes. What do I mean by that? Here's an example. So again, we're looking at a procedural approach. We're doing an HTTP GET to get the user. We're subscribing to that. But we also want to get the to-dos for that user. So we're subscribing to that as well. So we've nested another subscribe within this subscription. So how do we do this code without doing this? Well, the best answer is to go reactive and to use the approach that we just talked about. So if you want to resolve this, but still stay procedural, there's a way to do that by using higher order mapping operators. So here we're using a switch map. So in this case, we have our original HTTP GET. We have our first HTTP GET where we're getting the user and we're subscribing. Then inside, we're issuing this HTTP GET to get all of the to-dos. By using switch map, which is a higher order mapping operator, it will automatically subscribe to its inner observable. And just a little terminology here. This confused me when I first read it in the documentation. When you look at it on a picture, it's kind of obvious that that's the inner observable inside here, and this is the outer observable on the outside. But when you're just reading it in the documentation, it's not as obvious. But that's that terminology here. And of course, the #1 best practice that I can recommend when working with RxJS is just to have fun. With that, I want to thank you very much. You can get the code for this session here. Thank you.